Welcome to Spring LIB.
Okay, we're looking at question 2872, where we have a circular loop with current I2 going clockwise. And then we also have a wire down here with a current, but we don't know what direction the current is going in. But we want the magnetic field at the center of this loop, so this point right here, to be 0. So what that means is the magnetic field from this loop is going to have to cancel out the magnetic field from this wire. So first, let's figure out the magnitude of the magnetic field coming from this wire. So here's the expression for the magnetic field from an infinite line of current. So here we have this, we're talking about the this wire down here. So this is I1. And the distance that we're talking about here is going to be D. So this is our, let's call this B1, the magnetic field coming from this current down here. And again, we don't know which direction this is going to exert on yet. So now for B2, we have a loop of current, and we're looking at the magnetic field right in the center. So the expression for the magnetic field from a loop of current is going to be, we have mu naught times I2 here. This is the numerator. And then in the denominator is 2 times the radius. And the radius here is R. So this is going to be the magnetic field coming from this loop. And we do know the direction that this is going to be in because we can use the right-hand rule. So using the right-hand rule, curling our fingers around where the current loop is going, that means that it's going to point into the board or into the page here. So we want, we know that this one is going to be into the page. So we know that this is going to need to be out of the page in order to cancel it out. So let's just figure out the direction of the current here right away, since we know before we get the magnitude. In order to get a magnetic field out of the page from a current here, we know that this current is going to need to go to the right, because if we have a current going to the right, again, if we point our thumb in the direction of the magnetic field of the current here, that will give us a magnetic field coming out of the page at this point. So we now know the direction that I1 has to be. So now all we have to do is find the magnitude. So we know that at this point we want B1 to be equal to B2, because that will make the net magnetic field equal to, or I'm sorry, B1 has to be equal to negative B2, because we know B1 plus B2 has to equal 0. So we want to just set B1 equal to minus B2. So let's set mu naught I1 over here over 4 pi d equal to minus B2. So this is just making the sum equal to 0. Now what we want to do is solve for I1. So to do this, let's just cancel out the terms that we can. So we see a mu naught in both of these terms. So let's get rid of that to make it easy. We could cancel out a factor of 2. So let's multiply both sides by 2. That's going to turn this into a 2 instead of a 4. And now that's kind of all we can do. So again, we're solving for I1, so let's just multiply both sides by 2 pi d. So we're going to get this, pi d divided by r. We just got rid of this part. And the negative sign here is a bit unnecessary because we're just looking at the magnitude. Remember, we already figured out the direction. So we can kind of just ignore the minus sign here, but this is going to be our final expression for the magnitude of the current I1 in order to make the magnetic field at this point 0.